Have you ever stopped and wondered what kind of invisible power can literally rip a tree out of the ground or create a huge flash of lightning in the sky? Well, today, we're going to pull back the curtain and uncover the science behind some of the most powerful forces on our planet. We're diving into the hidden world of pressure, wind, and storms. Just look at this scene for a second. The wind is so strong, it's bending these massive trees, and you can see a huge storm just rolling in. We can see the effects, right? The chaos is obvious. But what's the invisible force actually causing all of this? That's the exact mystery we are setting out to solve right now. And to get us started, here's a kind of a wild thought. Could the air that's all around us right now actually have enough force to crush us? I know, it sounds completely impossible, but believe it or not, the answer to that very question is the first big clue we need to understand the incredible power of storms. All right, so first up, let's explore this invisible push. It's a force we all feel every single day, even if we don't really notice it. You for sure felt this before. The wind pushing against you or making leaves just dance across the ground. That push, it's a real force, and it creates something we call wind pressure. This right here is the very first piece of our puzzle to figuring out how those massive storms work. But what is pressure, really? Let's break it down with a super simple everyday example that actually holds the key to this whole weather mystery. Okay, so meet Mega and Pawan. They're carrying bags that are completely identical. They weigh the exact same amount. But while Mega's just walking along totally comfortable, Pawan is in pain. His bag is really hurting his shoulders. So what's the difference here? Take a close look at the straps on their bags. And this illustrates the concept perfectly. Pollen's got these narrow straps, and they concentrate all the bag's weight, that's the force, onto a really small area on his shoulders. This creates high pressure, and that's why it's so uncomfortable. Now, Mega's bag has broad straps, which spread that very same force out over a much larger area. The result? Low pressure. Much more comfortable. So here it is, the secret formula. Pressure is just the amount of force divided by the area it's applied to. Think about it like a sharp knife. Why does it cut so well? Because all the force you're pushing with is concentrated on that tiny, tiny edge. That is exactly what's happening with Pawan's bag. Way too much force on a small area creates painful, high pressure. Okay, now that we get the basic idea of pressure, let's scale it up, like way, way up. How does this same principle apply to the giant ocean of air that's sitting above our heads right now? The atmosphere. What's so cool about this little test is that it makes that invisible force completely visible. So when you press a rubber sucker down on a table, you're pushing all the air out from underneath it. That creates a little pocket of low pressure. Meanwhile, the air outside is at a much higher pressure and it pushes down on the sucker, holding it stuck to the surface. That is atmospheric pressure in action. So just how strong is this atmospheric pressure? Okay, get ready for this because it's pretty wild. The weight of the air pushing down on an area that's just the size of your hand is about the same as having a 225 kilogram weight sitting on it. That is an absolutely incredible amount of force pushing down on us all the time. Which, of course, brings us right back to our original question. If there's that much weight, why aren't we crushed? Well, the answer is balance. The pressure inside our bodies is pushing outwards with the exact same force that the atmosphere is pushing inwards. It's a perfect balancing act, and it's so perfect that we don't even notice this immense weight. And now we get to the golden rule. This is the rule that drives pretty much all of our weather. It's simple. Air is always trying to balance itself out. So air will always move from an area of high pressure to an area of low pressure. And that movement, well, that's what we call wind. So we've got pressure differences, and that creates wind. That's our basic recipe for weather. But what happens when we add two more critical ingredients to the mix? Heat and moisture. Well, that's when we start cooking up a real storm. It's like a 5-step chain reaction. Okay, step 1, warm, moist air starts to rise, and that creates the low pressure area we just talked about. 2, as that air gets higher, it cools down and clouds start to form. 3, inside that cloud, tiny particles of water and ice are rubbing together, building up a massive amount of static electricity. 4, then, all of a sudden, that charge gets released in a brilliant flash of lightning. And finally, 5, that lightning bolt superheats the air around it, causing a massive sonic boom that we hear as thunder. Now, thunderstorms are incredibly powerful, for sure, but under just the right conditions, this whole process can get turbocharged into something much, much bigger. Let's move on to the ultimate storm, the cyclone. A cyclone is basically a thunderstorm on steroids, and here's how it's born. First, as rain forms, it releases a tremendous amount of heat. Second, this heat makes the air rise even faster, which creates an even more intense low-pressure center. Third, air from all the high-pressure zones around it comes rushing in to fill that void. And fourth, the spin of the Earth itself makes all that rushing air start to rotate, creating a giant swirling cyclone. And right at the very center of this spinning giant, there's this really fascinating, almost eerie feature, the eye. It's a totally calm, low-pressure area where the winds are actually pretty light, but don't let that fool you. Just outside the eye is what's called the eye wall, and that's where you'll find the most violent winds and heaviest rain in the entire storm. See, a cyclone gets all its fuel from the warm, moist air over the ocean. The second it moves over land, it's like its fuel line gets cut. It starts to weaken pretty quickly. But even as it's dying out, a cyclone can leave behind an absolutely devastating trail of damage from its high winds and flooding. Understanding how these storms work is absolutely vital for our safety. So here is the really important stuff you need to know. Always follow official weather warnings. Always. Have an emergency kit ready to go. If an evacuation is ordered, you go. And during any thunderstorm, stay away from tall trees and water. Believe it or not, a car is one of the safest places you can be. So there you have it. We've uncovered the secrets behind pressure, wind, and storms. But all of this leads to one final and really crucial question. We know that these storms are fueled by heat and moisture. So as our planet changes, as it warms, how is that going to affect the power and the frequency of these incredible events? You see, understanding these fundamental forces, it isn't just a science lesson. It's going to be absolutely essential for navigating our future.